In this review problem, we're going to apply the rational root theorem to find all the zeros of a polynomial, in this case g of x. We start by looking at the leading coefficient of the largest degree term and at the constant. So here's the leading coefficient, 2, and here's the constant term, 3. So what we do is we find all the factors of the constant term, in this case 3 and 1, and we divide that by all the factors of the leading coefficient of the largest degree term, in this case 2 and 1. And what we do is we come up with each pair as a plus or minus of that quotient. For example, 3 over 2 is 3 halves, so we know that plus or minus 3 halves are possible roots of the polynomial. Then we have plus or minus 3 over 1, plus or minus 1 over 2, and plus or minus 1 over 1. So all I'm doing is I'm taking each factor pair, or it's not factor pair, but just a factor in the numerator over each factor in the denominator. So 3 over 2, 3 over 1, then 1 over 2, and 1 over 1. So what we have is we have 8 possible rational roots of the polynomial. We reduce these, so it's plus or minus 3 halves, plus or minus 3, plus or minus 1 half, and plus or minus 1. Lots of ways you can try to find where to start, because we're going to synthetically divide, but which one do we choose? Well, you could just brute force it and go through each one individually, but because we know that at one of these, or 2 of these, or most likely, obviously, 3 of these, because we're going to have 3 roots, we're going to have some that become 0, where g of x is 0. So a good place to start is always with 1. Why not? It's the easiest one to calculate. So 2 times 1 cubed plus 3 times 1 squared minus 8 times 1 plus 3. What does that equal? That's 2 plus 3 minus 8 plus 3, which does equal 0. So eureka, right off the bat, we found one that we know is a root. So let's synthetically divide that. 1 into 2, 3, negative 8, and 3. Bring down the 2, multiply by 1, get a 2. 3 plus 2 is 5, times 1 is 5. Negative 8 plus 5 is negative 3, times 1 is negative 3. 3 plus negative 3 is 0. That's expected. We were hoping that it would be a root, and we didn't make a mistake. So what we have left is the polynomial 2x squared plus 5x minus 3. Now we could continue to just chug through and find more that would synthetically divide. However, this is a quadratic, and let's see if we can factor it first. So 2x squared plus 5x minus 3 breaks down into 2x and an x, and then a 3 and a 1 is positive, that's minus, and there we go, it's factored. And so essentially we're done now. G of x equals x minus 1. Where'd that come from? That's the one that we were able to do off the bat. And then 2x minus 1, and x plus 3. And there we have it, g of x in factored form.